Hello everyone, happy Friday. Hope that you're able to get your work done at a decent time today and then enjoy your weekend. Today we're going to be looking at lesson 1.6. Now, 1.6 in a lot of ways, like the format of it, is going to be very similar to 1.5, to yesterday's lesson. Remember, in yesterday's lesson, we went over some vocab words, things like acute, which remember is a nice little acute angle, which is less than 90 degrees. Words like obtuse, which remember, obtuse angles are huge. They're over 90 degrees, right? We also went over a right angle. We went over a straight angle, some other things like the interior, exterior angle, all that good stuff. But really what we went over is a lot of terms, and then you went to apply those terms. And that's going to be very similar to what we do today. We have some new terms that might be new words, but very familiar ideas, and then we're going to see how we use those terms in application. So our learning targets for today, students will be able to define complementary angles, supplementary angles, a linear pair, vertical angles, that should say, and vertical angles, and you'll be able to identify them. So you'll be able to define and identify those terms right there. Also, students will be able to use algebra skills to solve problems with various angles. So again, just like yesterday, we're going to go over these terms, and then we're going to put you in situations where you need to use some algebra to find the measure of different angles and things like that. So let's first dive into some terms. The first one I want to look at right here. Oh, one thing I need to mention before I get too far. This would be, out of all the lessons we've had so far today, this might be one of the most helpful ones if you're following with me in your textbook, or at least have your textbook readily available, because when you're doing your homework, you might want to refer back to these terms. So we are on page 48. If you want to follow with me, or just know that we're in section 1.6 for when you're doing your homework, you can check these things out. So anyway, what was I saying? Here we go. The first term we want to look at is like complementary angles. And our formal definition of a complementary angle: two positive angles whose measures have a sum of 90 degrees. Each angle is the complement of the other. So in this first example, you can kind of see we have a right angle, and we know because of the little half box there. And then if we have something that splits up that right angle, well, then obviously this 1 plus 2 has to equal that whole 90 degrees. So that's a pretty obvious example. Here with angle A and angle B, angle A is 20, angle B is 70. If we add those two things together, we would get 90. So those two angles, we would say that angle A is the complement of angle B. And there's not like a cool symbol for complement or anything like that. Maybe we should come up with one, but I can't think of anything right now. So we just say that angle B is the complement, or angle A is the complement of angle B. They kind of go together there. So the complement is when the sum is 90 degrees. Now over here, the supplement is when the sum of the two angles is 180 degrees. Okay, so I'll read this whole formal definition here. Two positive angles whose measures have a sum of 180 degrees. Each angle is the supplement of the other. So just like earlier, 115 plus 65 would give us 180. So we say that angle C is the supplement of angle D. Those two go together. Remember, any perfectly straight line or straight angle that we talked about yesterday has a measure of 180 degrees. 180 degrees. So when we see this line, we know this whole thing is 180 degrees. If we take just angle 3 plus angle 4, then we will see that that has to give us 180 degrees. And we know that because of a certain postulate that we talked about yesterday. We talked about this postulate with segments. If we were in class, I 100% would ask this question. What postulate is it called? And yes, very good. It is the angle addition postulate that we know that if we add this together and add this together, that will get the whole thing. So very good. Last term on this page is adjacent angles. Adjacent angles. So two angles that share a common vertex. Here's our common vertex, very nicely labeled for us right here. And a side. Here's our common side, nicely labeled for us once again, but have no common interior point. So we can see common vertex, common side, but they don't share any inside points at all. Any interior points don't overlap. So that's just an adjacent angle, pretty much saying that they share a side. So we've seen adjacent angles all the time. I mean, oops. Here would be an adjacent angle. This would be an adjacent angle. Right here, A and B would not be an adjacent angle because they don't share a side. Same here, C and D would not be adjacent angles because they do not share a side. So you're probably looking at these terms and you're thinking, how are we going to have a question that deals with these terms? Well, let's take a look. Angle 1 is a complement of angle 2. So right away when we see the word complement, we should be thinking that complement means sum of 90 degrees. So if angle 1 is the complement of angle 2, that means that angle 1 plus angle 2 has to equal 90 degrees. And the measure of angle 1 is 62 degrees. Find measure of angle 2. Well, we just said angle 1 plus angle 2 has to equal 90 degrees. So if we, 2. The measure of angle 2 has to be 28 degrees. So this is a very simple form of how we will see a complement or supplementary or adjacent angles put into a problem. A lot of times there's going to be more algebra than this, but really the key thing as you're doing the homework and reading through these problems is that you identify and know, okay, are we talking about two complements, supplements? We'll get into a couple other terms here in a second, but really being focused on those details of what words they're using will be helpful there. All right, a couple other terms. The first one, we'll start on this left side. Two adjacent angles are a linear pair. I need to start again. Two adjacent angles are a linear pair when their non-common sides are opposite rays. So if we look at our picture here, here's the vertex where these two rays, the endpoint where these two rays come together. So here's the non-common side, and they form opposite rays with an endpoint right here. The angle is a linear pair, or the angles in a linear pair are supplementary angles. So by definition, first thing, if we have opposite rays, this is something that a lot of people missed on the quiz. If we have opposite rays, that means that they're on kind of the same overall line. An opposite ray could not be something that looks like this. This could not be an opposite ray. And that's what a lot of people mixed up on the quiz. Remember, opposite rays share the endpoint, but also would form a line if you put them together. So the angles in a linear pair are supplementary. So since they are opposite rays, then that means that their measure has to be 180 degrees, so it makes sense that they're supplementary. Okay, so we would say that angle 1 and angle 2 are a linear pair, which linear, a line, a pair, right? 1 and 2 are a pair that make up a line. A linear pair is very similar to our supplementary angles, right? Because they both have to be 180 degrees. Another term, going to the left side, or the right side, hello. 1, no, everything's 2. 2 angles. 2 angles are vertical angles when their sides form 2 pairs of opposite rays. So let's take a look at this picture. Vertical angles. So here is one, that's not dark enough. So here's one opposite ray, or one pair of opposite rays. Here's another pair of opposite rays. So we could say that 3 and 6 are vertical angles. We could also say, it's also true, that 4 and 5 are vertical angles. And vertical angles, something that is important, you're like, okay, what is a vertical angle? When they're vertical angles, that means they have the same measure. So we can see, and this picture shows it very well, but angle 4 and angle 5 have the same measure. And that is because, if we were like proving this, we could say angle 4 is congruent to angle 5 because they are vertical angles. Same thing with angle 3 and angle 6. Angle 3 and angle 6 are congruent. They have the same measure because they're vertical angles. So in a problem, if they tell you, hey, angle 1 and angle 4 are vertical angles, what they're trying to clue you in on is saying, hey, these two things have the same measure. All right, so if we look at number, well, it says number 6, but our 5th slide, we have a problem that looks very similar to what we'll see on the homework. And the question it would say is, find the measure of each angle. So find the measure of angle WXY and of YXZ. So first it says angle WXY, so I'm just going to draw those. WXY and angle YX, whoa, I always do that, YXZ are supplementary angles. So remember, supplementary means that we're at 180 degrees, that they equal 180 degrees. So that means I should change my picture because YXZ So I changed my picture because my picture didn't have this straight angle here. Because if they're supplementary, that means we know that they have to add up to 180 degrees. So I just want my picture to reflect that a little bit better. It might not be perfect, but it'll give me a better idea. So we know these two things are supplementary. WXY is 6x plus 59 degrees. And YXZ is 3x minus 14. We need to find the measure of each individual angle. So the way that we do this is that we know that the measure of angle WXY plus measure of angle YXZ has to equal 180 degrees. Well, WXY is 6x plus 59, and YXZ is 3x minus 14. Now we can do some simplifying and some solving, but what we want to do is solve for x. Eventually, after simplifying, we'll see that x equals 15. And we're not done yet because they said they want the measure of each angle, so we need to take this x equals 15. We need to put it into here and put it here. So if we have 6 times 15 plus 59, that would give us 149. And 3 times 15 minus 14 would give us 31 degrees. So our answer then, we would say measure of angle WXY is 149 degrees. Measure of angle YXZ equals 31 degrees. So this is a lot more realistic and very close to what you'll have again on the homework. All right, last example. The measure of an angle, so let's stop right there. We have some type of word problem, and I forgot I didn't put the directions on here. So we have a word problem, and the directions are going to say something like write and solve an algebraic equation to find the measure of each angle based on the given information. So we have to write an equation, and then we have to find the measure of each angle that we're talking about here. So it starts out saying the measure of an angle. So we have some unknown angle that it tells us about in the beginning. We'll just call it x. And the measure of this angle is 9 more. So when we see 9 more, we're not talking about multiplying. 9 more than twice its complement. So 9 more than twice, or 9 more than double. So we have our original angle, and that's x. And then our new angle, or the complement of it, is 9 more. So this original plus 9, then twice the complement. So if we take this first one and we double it plus 9, that'll give us what the second angle is. So the way we would write this in an algebraic expression would be that x plus 2x, or x plus 2x plus 9. And again, this kind of represents, this outside x represents our original angle that it's talking about. Inside the parentheses, that shows us the adjustments that we made here. So that's our algebraic expression. Now we need to solve. Well, if we're going to solve it, we need to set it equal to something. In the direction, not in the directions, in the problem here, they told us that we are dealing with angles that are complements. So if they're complements, then we know that that means that they equal or add up to 90 degrees. So it looks like to me, if we solve for x and use that to find our original angle and then find the changes we made, then we might be able to get the right answer here. If we do a little bit of algebra, you'll find that x equals 27. Now, like we said, x is our original measure, or kind of our original angle that we started with. So we know that one of them is 27 degrees. Now there's a couple ways that we could find the second angle. If we know it all has to add up to 90, we could just do 90 minus 27, and we could find that the second angle equals 63. Or you could take our x and plug it into our new equation that we made from those words. So a couple ways you can find it. I think it's easy. Once you find x, and if you know that your original angle is x, then you can just subtract it from 90, or if you're dealing with a supplement angle, you'd be subtracting from 180. You just have to be careful with that vocab. So if we look at our learning targets, we talked about complementary angles. We talked about supplementary angles, a linear pair, vertical angles, and then we did some work to, well, we didn't do too much to identify them. In the homework, it's going to have some things where it gives you a picture, and it says, okay, name the angles that are vertical angles, name the angles that are supplementary, complementary, a linear pair, all that kind of stuff. So you'll get that practice of identifying them in the homework. But we went through at least to define them. Students will be able to use algebra skills to solve problems with various angles. That's exactly what we did right here. This was a word problem, and we used algebra to find what x was. And same thing up here. We were dealing with different types of angles, and we had to use algebra to find what the measure of those angles were. So that's all I have for today. I know that I talk pretty quickly through those terms. So if you have questions, make sure that you let me know. Again, especially when we're dealing with all these terms, the book is a very good resource that if, while you're doing your homework, if you want to keep saying, oh, I can't remember which one complementary is, which one supplementary is, just keep your book open and look at that as a reminder for which one is which. All right. Again, hopefully you're getting this done at a good time on Friday and getting your worksheet taken care of, so then you can go enjoy your weekend.